In 2016, China opened a bridge made entirely of glass, suspended 300 meters above a canyon so deep the bottom vanishes into cloud. Engineers said it could not be done. Geologists said the canyon itself was unstable, and yet 600 people walked across it on opening day, looking straight down at the earth beneath their feet. But this bridge is not even the most extreme thing China built, because somewhere in the western desert, there is a highway that should be buried under sand, a dam that measurably slowed the rotation of the Earth, and a telescope that can hear signals from 13 billion light-years away. 5 structures, things that engineers, geologists, and physicists said were either impossible or insane. China built them anyway. The Zhangjiajie Grand Canyon, Hunan Province, China. The canyon walls here rise 300 meters straight up from the valley floor, sheer and vertical, carved over 300 million years by water and geological pressure. The rock formations that fill this valley are unlike anything else on Earth. Sandstone pillars rise hundreds of meters from the valley floor and then simply stop, flat-topped, like someone sliced them with a blade from above. For most of recorded history, the only people who crossed it were birds. Then, in 2012, a Chinese architect named Haim Dotan received a brief from the Hunan provincial government. They wanted a tourist attraction that would put Zhangjiajie on the global map, something nobody had ever done before. Dotan's response was a bridge made entirely of glass, 430 meters long, 6 meters wide, suspended between 2 cliff faces at 300 meters above the valley floor. The longest, highest glass bridge ever proposed. When he presented the design, the first question from the room was whether it was physically possible. His answer was that they would find out. China did not build a steel bridge or a suspension bridge with a solid floor. They built a bridge with a floor made entirely of glass. The engineering problem nobody in the industry wanted to say out loud was this: glass, at this scale, under this kind of load, had never been tested before. There was no playbook, no existing lamination process that could handle the stress of hundreds of people walking on a single pane, 300 meters above nothing. Standard architectural glass would have shattered on contact. Even laminated safety glass used in skyscrapers was not designed for foot traffic loads at this span. So a team of materials engineers spent 2 years developing a 3-layer laminated glass specifically for this project. Each panel bonded with a polymer interlayer that would keep the glass together even if the outer layer fractured. The same principle used in car windshields, but scaled to panels a meter wide and carrying the weight of dozens of people simultaneously. To prove the design, they ran a test that they filmed and posted publicly. A worker stood on a single panel and swung a sledgehammer directly into the glass surface. Once, twice, a third time. The outer layer cracked on the second blow. On the third, it spiderwebbed completely. The panel held. Each panel, once installed, was rated to hold 40 times its own weight. The bridge was designed for a maximum load of 800 people at one time, and on opening day in August 2016, they put 600 people on it simultaneously just to see what would happen. Nothing happened. The glass did not move. 2 weeks later, the bridge was closed. Not because anything failed, but because the crowds were so large the province could not manage the safety logistics. An estimated 80,000 visitors had come to Zhangjiajie in a single day, a number the local infrastructure had never been built to handle. The bridge reopened the following month with a ticketing cap. But the detail that changes the entire story of this place sits underneath it. This canyon is the exact location that inspired the floating mountains in the film Avatar. James Cameron's team pulled the visual reference directly from these rock formations, which locals had called the Avatar Hallelujah Mountains since the film's release in 2009. So when you walk across that glass floor and look down at those mountains rising from the valley below, you are standing inside the landscape that launched one of the highest-grossing films in history. Some say that was not a coincidence, that the decision to build the world's most extreme glass bridge in this specific canyon, in a region already drawing millions of visitors because of a Hollywood film, was a calculation made at a level above the architects. China invested approximately 2.4 billion yuan in the Zhangjiajie tourism district in the years surrounding the bridge's construction. The bridge itself cost around 350 million yuan to build. In its first year of operation, the region generated an estimated 10 billion yuan in tourism revenue. That is not an accident. That is a country that understood exactly what it was doing, but the glass bridge was just a warm-up. For 1,000 years, the mountain ranges of Sichuan province in southwest China had a reputation. Locals did not call them impassable. They called them something more specific than that. They called them the place where roads go to die. The Li Bai, one of China's most revered poets, wrote about crossing these mountains in the 8th century. His poem was called The Hard Road to Shu. The opening line translates roughly as, "The road to Shu is harder than climbing to heaven." That poem is over 1,300 years old. It is still accurate. The Zhangjiajie Mountain Expressway project began formal planning in 2015. When the preliminary geological survey came back, 3 separate engineering firms said the route was not viable. The rock formations in the target zone had never been mapped in detail because no one had ever tried to build through them. China hired a 4th firm and told them to map it anyway. Construction began in 2017 and took 5 years. 270 viaducts and 25 tunnels blasted through solid rock. At its peak, 30,000 workers were on site simultaneously across a construction zone stretching 240 kilometers through the mountains. The tunneling alone produced enough excavated rock to fill over 200,000 standard shipping containers. Crews worked in rotating shifts around the clock because the rock temperature inside some tunnels reached 45 degrees Celsius. Hot enough that workers could only safely stay inside for 90-minute rotations before being rotated out. There were accidents. In 2019, a section of viaduct formwork collapsed during a concrete pour, injuring 7 workers. In 2020, unexpected groundwater flooded a tunnel section that had been considered dry by the surveys. The crew inside escaped, but the machinery did not. Construction continued. Workers nicknamed it the highway in the sky, and when you see it from above, you understand why. In sections, the road sits at the same elevation as the mountain peaks beside it. The viaduct pillars drop 200 meters to the valley floor below. Driving it feels less like a road and more like a runway suspended in open air, because in sections that is functionally what it is. The longest single viaduct on the route spans 1.3 kilometers across a valley that no bridge had ever crossed. Engineers had to design a new type of high-pier viaduct construction method specifically for this project, because the existing standard methods could not safely handle pillars at this height in this geology. That method is now used on other Chinese mountain highway projects, international engineering publications noticed. In 2023, the American Society of Civil Engineers referenced the Zhangjiajie Expressway in a report on high-altitude road construction as a case study in solving problems that Western engineering codes had not formally addressed. But before this highway opened, there were villages in this range that had not had physical road access to the rest of China in living memory. Goods moved on foot, kids walked hours to reach schools, and a medical emergency meant a helicopter or nothing at all. One village in the range, documented by a Chinese journalist in 2021, had been cut off from a major road for so long that the village's oldest residents had never once left the mountains in their entire lives. The highway changed that overnight. When the road opened in December 2022, the first vehicles to drive it were not government officials or engineers. They were supply trucks carrying goods to villages that had been waiting years for access. The second were school buses. The Three Gorges Dam, the largest hydroelectric dam ever built, 2 kilometers wide, 185 meters tall, with a reservoir stretching 600 kilometers behind it, roughly the length of Lake Superior. The project was first proposed in 1919 by Sun Yat-sen, the founder of modern China. The engineering surveys began in the 1950s. Construction did not start until 1994. The dam that took 75 years to move from idea to groundbreaking is the dam that then took 12 more years to complete. More than 1.3 million people were relocated to make way for the reservoir. Entire towns, some of them thousands of years old, were permanently flooded. Archaeologists scrambled to document and excavate historical sites before the water rose. 1,300 documented cultural and historical sites now sit under the surface of the reservoir. The human cost of this dam is a number that does not fit neatly into an engineering report. But the dam was built, And when China filled the reservoir in 2003, something happened that geophysicists quietly noted in their instruments and debated for years afterward. The weight of 39 trillion kilograms of water, concentrated in one location, measurably shifted the distribution of Earth's mass. Earth's rotation slowed. Fractional and invisible to any human sense, but measurable and documented and real. NASA's Goddard Space Flight Center published the calculation. Dr. Benjamin Fong Chao confirmed it. The dam is so large it changed the physics of the planet it sits on. What if that was not a side effect? What if the engineers knew and built it anyway? The dam generates electricity equivalent to burning 50 million tons of coal every year, powers over 10% of China's electricity grid, and in the years since completion, has avoided an estimated 100 million tons of carbon dioxide annually by replacing coal that would otherwise have been burned. But cargo ships still needed to cross it, and a dam 185 meters tall is not something a cargo ship simply floats over. The original solution was a 5-step ship lock system. Vessels would move through a series of connected chambers, each one raising the ship by about 30 meters until it reached the top. The process took 3 to 4 hours per vessel. For commercial cargo shipping on the Yangtze River, the main artery of Chinese inland trade, that was too slow, so China built the largest ship elevator on Earth. A steel gondola filled with water, large enough to hold a 3,000-ton vessel, rises 113 meters in 40 minutes. The ship floats inside it the entire time, never touching the gondola walls, suspended entirely on water pressure and a counterweight system using 156 individual counterweight cables. The gondola alone weighs 15,500 tons when full of water. The counterweight system has to balance that load while simultaneously absorbing the vibration from the ship's engines, the wind load on the gondola structure, and any seismic activity in the region. German engineering firm Voith was brought in as a consultant during the design phase. Their report, submitted in 2004, described the project as technically feasible but operationally unprecedented. That report was used to justify continued construction. It was also the last time a foreign firm was formally involved. The final engineering was done entirely by Chinese teams. The elevator opened in 2016, 10 years after the dam was completed, because it took that long to solve the mechanical problems nobody had encountered before. And it quietly produced something few people outside the shipping industry know, a waiting list of countries now asking to license the technology, because there is one. But nothing on this list, not the glass, not the highway, not the dam, compares to what China buried in a desert that had swallowed travelers for 1,000 years. Stop for a moment. 3 projects across 3 completely different engineering domains: glass architecture, mountain highway construction, hydraulic dam engineering, and in each case the same sequence of events. A foreign or domestic engineering firm says the project is not viable. China commissions a different team and tells them to find a way. The project is built, and then the rest of the world studies it. This is not a coincidence. This is a decision-making architecture that other countries do not have. In the United States, the environmental impact review for a major infrastructure project takes an average of 4.5 years before construction can begin. In Germany, the planning and approval process for a new highway through sensitive terrain averages 12 years. In the United Kingdom, the HS2 rail project was proposed in 2009, began construction in 2020, and had already been partially cancelled by 2023. China broke ground on the Zhangjiajie Mountain Expressway 2 years after the geological surveys came back saying it was not viable. The obvious explanation is authoritarian efficiency. A government that does not need to consult, compensate fairly, or respond to opposition can simply decide and build. The 1.3 million people displaced by 3 gorges were not asked whether they wanted to move. They were told when. That is part of the answer, but it is not the whole answer, because the glass bridge was a tourist project, not a state necessity. The mountain highway serves villages that could have been reached by helicopter service for a fraction of the cost. And the FAST telescope, which you will hear about shortly, was built in a region of China that already had functional radio astronomy facilities. Something else is operating here. Some researchers who study Chinese infrastructure policy use a phrase that does not translate cleanly into English. The closest approximation is constructive ambition, the idea that the act of attempting something impossible changes what your engineers, your institutions, and your country believe is possible next. What if the glass bridge was never really about tourism? What if it was about proving to an entire generation of Chinese engineers that the word impossible is a starting point, not a conclusion? What if every project on this list is a message sent forward in time to the next generation of people who will build the next impossible thing? The desert was next. The Taklamakan Desert, central Xinjiang, northwestern China. For 1,000 years, the name alone was a warning. Caravans on the ancient Silk Road skirted its edges and nobody crossed the interior. Because the dunes move, the sand shifts, and men who walked into the Taklamakan did not walk out. The Taklamakan is the second largest shifting sand desert in the world, covering 337,000 square kilometers. The dunes here are not the gentle rolling kind. Some reach 200 meters in height, and they move. Under the right wind conditions, a major dune system can shift tens of meters in a single season. The desert has consumed entire caravans, entire archaeological sites, entire rivers. The ruins of cities that once sat on the Silk Road now lie buried under meters of sand. In 1993, the Chinese National Petroleum Corporation needed to access oil fields in the desert's interior. A road had never existed in that corridor, and building one was not, by any standard engineering assessment, considered possible. In 1995, China announced they were building a highway straight through the middle of it. The engineering community's response was polite skepticism. A delegation from a European road construction consortium visited the project site in 1996 and submitted a report concluding that a permanent road surface in the Taklamakan was not maintainable under current or foreseeable engineering approaches. The sand migration rates were simply too high. Any road surface would be buried faster than it could be cleared. China read the report. Construction continued. The core problem was not building the road. Laying asphalt across a flat desert surface is straightforward. The problem was keeping it clear. The dunes that flanked the highway corridor moved at a rate of between 5 and 10 meters per year. Without intervention, the road would be buried within 2 to 3 seasons. China's answer came from biology, not from engineering. They planted trees, and not dozens or thousands, but millions of them. Tamarisk, saxaul, and haloxylon species, drought-resistant, deep-rooting, sand-anchoring, forming a biological wall on both sides of the road, stretching the entire 522-kilometer length of the highway. Then they solved the next problem. The desert receives less than 10 millimeters of rainfall per year in some sections. Trees in the Taklamakan die in weeks without water, so they built an automated underground irrigation network, water pipes running the full length of the highway, feeding each tree on a programmed schedule, drawing from underground aquifers that geologists had spent 4 years mapping. The irrigation system runs automatically. Sensors monitor soil moisture at intervals along the route. If a section runs dry, the system adjusts. If a pipe fails, an alarm triggers at a maintenance station. There are 108 maintenance stations along the 522-kilometer route, each staffed by workers whose sole job is to keep the trees alive. What they created, without ever using the word, is a terraformed corridor through one of the most hostile environments on Earth. Some researchers now call this section of the Taklamakan a micro-ecosystem, a new climate zone created entirely by human infrastructure. The tree corridor has lowered local wind speeds, reduced sand transport, and created humidity levels measurably different from the desert 100 meters outside the corridor. A Chinese environmental scientist who published a study on the corridor in 2018 noted that bird species not previously recorded in the central Taklamakan had begun appearing along the highway route. Animals were following the trees. What does it mean when a country rewrites a desert's biology just to build a road? That question has no clean answer, but this last project is different from everything before it, because the others were built to move people, goods, or water. This one was built to listen. Somewhere in the karst hills of Guizhou Province, China, there is a bowl in the earth. Natural, Geological, a sinkhole the size of a small town, formed over millions of years as water eroded the limestone bedrock from beneath. Chinese astronomers first surveyed this sinkhole in the 1990s. They were not looking for a place to build. They were looking for a natural shape that matched an engineering specification, and this specific depression in the Guizhou Hills matched it exactly. In 2007, the Chinese government approved the construction of the 500-meter Aperture Spherical Telescope, FAST. The telescope measures 500 meters across, roughly the span of 30 football fields laid end to end. The previous record holder was the Arecibo telescope in Puerto Rico at 305 meters. FAST is 64% larger, and the gap in sensitivity is not proportional to the size difference. It is exponential. FAST can detect signals approximately 5 times fainter than Arecibo could at peak performance, and Arecibo held the world record for 53 years. 4,450 aluminum panels, each one independently adjustable, controlled by a system of cables and actuators that can reshape the entire surface in real time. The telescope does not point the way a traditional dish does. Instead, a section of the surface adjusts to form a parabola facing whatever the telescope needs to observe, while the rest of the surface waits in a neutral position. This means FAST can observe up to 40% of the sky from a single fixed location, compared to about 6% for Arecibo, and it can track a moving source, a satellite, a pulsar, a signal, continuously for up to 6 hours without losing lock. The sensitivity of this instrument is genuinely difficult to describe, but try this. FAST can detect a signal equivalent to a single mobile phone transmitting from the surface of Jupiter. Jupiter is 600 million kilometers away. The telescope is currently scanning the sky for signals from beyond the solar system. It is, right now, listening for extraterrestrial life. That is not a metaphor or a future ambition. It is a stated operational mission of the National Astronomical Observatories of China. It has already captured signals from pulsars, from neutron stars, from galaxies 13 billion light-years away, light that left its source before Earth existed. To protect it from interference, the Chinese government established a 5-kilometer radio silence zone around the site. Mobile phones, Wi-Fi, radio transmissions, all of it banned. Approximately 9,000 residents living within the zone were relocated before construction began, compensated and moved to new housing in adjacent towns. The silence around FAST is a legal requirement enforced by the Guizhou provincial government, not a cultural suggestion. Visitors who smuggle in devices have been fined. A researcher who brought an undeclared laptop in 2019 had it confiscated and was removed from the site. In 2022, FAST detected anomalous signals that did not match any known natural source. The announcement came through the state-affiliated Science and Technology Daily and was picked up internationally within hours. China's National Space Administration said the signals were under investigation. Within 2 weeks, an explanation was issued. The signals were attributed to radio frequency interference from satellites in low Earth orbit. Some researchers who reviewed the data said the attribution was technically plausible but unusually rapid for a peer-reviewed conclusion. Nobody is making that claim officially. FAST is the most sensitive ear humanity has ever built. It is pointed at the sky, and the people operating it have gone to extraordinary lengths to make sure nothing on the ground gets in the way of whatever it is trying to hear. But the telescope keeps listening. And whatever it is listening for, China made sure the entire country stays quiet enough to hear it. Take a step back from the engineering. The glass bridge invented its own material to exist. The mountain highway solved geological problems that had never been named before the project began. The dam rearranged the mass distribution of the planet. The desert highway grew a climate zone from scratch, and the telescope is listening to the edge of the observable universe. Every single one of these projects began with a report from engineers saying it could not be done. Every single one was built anyway, and in every single case, the act of building it created knowledge that did not exist before. New glass lamination techniques now used in buildings around the world. New high-pier viaduct construction methods now used across Asia. New hydrostatic engineering principles now being licensed internationally. New desert biology that is being studied as a model for climate adaptation. When people talk about China's infrastructure, they focus on the structures, but the structures are not the product, the knowledge is the product, and the structures are just the proof that the knowledge was generated. When you watch a country build 5 things that should not exist, things that required inventing new science to complete, what do you feel? Because I have watched this footage dozens of times while writing this, and I still cannot settle on a single answer. There is brilliance in it, and will, and something that looks like a civilization trying to say something to the future through the only language that cannot be mistranslated. Stone and steel and glass and light. When one country builds 5 things that should not exist, is that engineering, or is it something else entirely? Now you know about the glass bridge that invented its own material, the mountain highway built through terrain that broke every road before it, the dam that physically changed the rotation of the earth, the desert highway that grew an ecosystem to survive, and the telescope listening for something we have not found yet. Next video, I am going into the engineering failures that China does not talk about, the projects that came before these ones, the ones that did not make it, and what they cost. Click that video. I will see you there.